Okay, it looks like the number of participants in the audience is stable now. So I want to introduce to you Andrei Kropil. He is a cloud architect at WEDOS. So, and WEDOS is a company operating in the Czech Republic or out of the Czech Republic. And Andrei is originally from Russia, had his education in Moscow, and currently in Czech Republic. And I'm pretty sure we will hear a lot from him in the future. Andrei, it's yours.
Thank you, Philip. Hello. My current subject is LINSTOR and DRBD on 600 nodes. And let's start. First, few words about our company. As Philip already introduced, we are Czech hosting. We are biggest hosting in Czech Republic. We have 2 own data centers, and we run hundreds of thousands of virtual of sites, of websites, and thousands of virtual machines. And we have thousands of physical servers. And we actively use Kubernetes and PXE booting to operate them. This is how our first data center looks like. The second one was built not so far ago. It was built with one interesting technology. We use oil bath and oil conditioning here. This is exactly meaning that we putting all our servers exactly into oil. This looks like really beautiful. And yes, we also running our LINSTOR nodes on these servers. And now I will introduce you our infrastructure. This is typical scheme of our cluster. We have really many nodes. We have clusters with many nodes inside. And usually clusters are divided to 2 groups. One group is control plane nodes. These nodes are making everything to support all other nodes, to make them working. And the other nodes, actually compute nodes, they are just running workload. We have no any separated storage boxes. We run storage exactly on the same nodes, on the same compute nodes where we're running our workload. And LINSTOR support help us to doing that. This is how they looking like. This is HP moonshot. It's like 4 unit high, and it has 45 cartridges inside. And each cartridge is having 10 gigs network interface. It has 4 cores Intel CPU, 8 sockets, and can have up to 64 gigs RAM installed. And the most important thing that you can install there up to 4 NVMe devices. For now, we use NVMe devices no more than 1 terabyte size. And we have various types of these nodes. Usually these nodes having 4 devices or just 1. We also having some fully diskless nodes which have no any devices and any storage installed on it. But we're still running LINSTOR there for having an opportunity running some workload, which is working with the volumes from the other cartridges. I just want to say that these nodes have no any persistent operating system installed. They are booting over the internet, over the network, from the PXE servers installed on the control plane nodes. This is how it looks like. First, when you enable your, when you start your nodes, they going to the DHCP, asking for the IP address, and then downloading image from the netboot server. After they downloaded their rootfs image, they somehow boot it, and after that they don't need to have established connection with these PXE servers anymore. And after the first thing, after they boot it, they connecting to the Kubernetes cluster, which allows to Kubernetes to distribute the workload to run containers on these nodes. And LINSTOR running the same way inside these containers. You should understand that we can't install anything on these nodes because after reboot, these changes will be lost. This is also fine because we can update them quite fast. It's just a reboot enough to reboot to update the node. So and yeah, just interesting information that currently I'm also working on another project. I'm going to run containerized Kubernetes also here, and the nodes will be joined into own separated cluster. This is needed for the better isolation and better stability. We're also going to run multiple LINSTOR clusters to split the roles and having better redundancy here. So back to storage, here on this screen, you can see all the file systems which we've tried before we become the decision to use the LINSTOR. You can see here is quite many of them. The problem is that first and foremost, we were looking for high performance. And we've tried many of these solutions. Many of them were not providing this performance to us. But the other part was not providing a stable environment. We prepared some crash tests and we were trying to reboot our nodes randomly. Usually they were losing the data. So, and we made decision to use DRBD. First, we were using DRBD because LINSTOR wasn't ready to production yet. We had own orchestration for DRBD devices. It was running on top of, it was running the same way in the Kubernetes. And they were also running high available iSCSI targets and NFS servers right inside Kubernetes. And we were using it. We were happy with that. But after a while, it was there were decisions to switch to LINSTOR because it was already exactly the thing which we do, but with a better interface, with more features. And this is like official tool for them managing DRBDs. The first thing which I want to say about the LINSTOR, it's not clustered file system at all. It's rather orchestrator. It's something like Kubernetes, but for block devices. Under the hood, it's having proven technologies like LVM or ZFS. And I want to say that it is really cool that it has a fully independent environment. I just want to say that you can have block devices created in data plane, let's say data plane, but control plane can be fully switched down for a while. All the data will not be lost and replication will continue working. All the devices will still existing in the cluster. And the main thing of the LINSTOR that it is really fast and simple. We don't like difficult scenarios of clustered file system that because every tool which you use, every clustered file system, it can be broken. And when the LINSTOR is broken, it's also happening sometimes. You exactly know that your data will be saved. Even if a control plane is not accessible, you can always go to the node physically over SSH and get your data back. So this is ensured by proven technologies. As I say, LINSTOR is use standard LVM and ZFS, and other, it can use simple files, loop devices, and even NVMe over fabrics, but we're not using it. And just enables DRBD for the replication. And the main thing that we've tried, yeah, I already mentioned that we've tried all these file systems, LINSTOR, or actually DRBD passed all our crash tests. So we were rebooting our nodes. The data weren't lost at all. and it was really cool. So now a few words about how do we use LINSTOR. Actually, we have 3 platforms where we use it. First is Kubernetes. All our new infrastructure is based on Kubernetes. So we're using LINSTOR there quite high. For the deploying Kubernetes, for the deploying LINSTOR on Kubernetes, I prepared a special Helm chart. It's called project is called KubeLINSTOR. It was started even before the official Piraeus operator, and we still continue using it because it's simplest and easiest way to get LINSTOR on your bare metal infrastructure. I'm not talking about the clouds. Maybe cloud way will be easier with the Piraeus, but I'm sure that if you're deploying LINSTOR on bare metal, KubeLINSTOR will be better. I don't know. This is just my opinion. It's maybe not connected with the guys from the LinBit. Okay, the next thing, we use OpenNebula. We use it quite often. We use it for the user virtual machines, and also we have cloud service. It's like simple cloud service when you can get some resources and request some virtual machines. For the OpenNebula, we use also on-written driver. It's called LINSTOR on. Why we didn't choose official one? Because OpenNebula has a really bit different logic of operating. Usually it also has on control plane and compute nodes. And the official driver of LINSTOR is usually requires connection from the compute nodes to the control plane nodes, to the LINSTOR controller, sorry. And my driver does not require that. And it is also written on shell, so it can be simply debugged and simply extended. Many people from the community are also interested in that, and I saw they are really using that. And we're also using LINSTOR with the Proxmox. We have small Proxmox cluster just for 3 nodes, and we're running some services there, some our pet services, which is not needed to be updated quite often. For example, we're running domain controller there. We're running mail server, some infrastructure services, which it's like pet services. You know, you don't need to update them quite often. It is easier to just put them on some virtual machine and forget about it. I just want to say that official LINSTOR driver for Proxmox is working really fine, and I'm glad to use it. This is typical scheme of the LINSTOR. You probably saw that already. The main thing here is LINSTOR satellites and LINSTOR controller. LINSTOR satellite should be installed on every node where you're going to use the LINSTOR, even if this node is not locating any data, but you're going to use the volumes from the LINSTOR on these nodes. This node should have satellite installed. This is a service which is managing LVMs and DRBD configuration created on the node. LINSTOR controller are sending these commands to create and update devices resources to the LINSTOR satellites, and it stores its state on database. For the database can be used various databases. Usually it's Postgres, etcd, or file H2. It can be also MySQL, and many interfaces I saw are supported. And all the clients and drivers are communicating directly with the LINSTOR controller. Now short demo. I will show you our production cluster. It's the biggest one. Let's see stateful sets and daemon sets. Here you can see LINSTOR deployed through the KubeLINSTOR project. We see LINSTOR controller. which is exactly a controller for the LINSTOR and LINSTOR CSI controller. This is a bridge between the Kubernetes and the LINSTOR. It's sending commands to create new volumes, to attach them, detach, resize, create snapshots, and stuff like that. For the database, we use Stallone, which is this is actually a high-available Stallone in Postgres cluster. It's running from 3 nodes. And as you can see, it's already running for 2 years, 720 days. So this is age of our oldest LINSTOR cluster on production. This is how long do we use it. From the daemon sets, you see the same CSI node. This is part of CSI integration Kubernetes with the LINSTOR. And the satellites, we have 626 satellites for now. And this is actually a number of our nodes which we use for the LINSTOR. Okay, let's go and check node list. There is quite many of them. Let's check some properties. Each node can have own properties set. We have, for now, you can see 11 chassis, and each chassis have 45 cartridges. And each cartridge is actually a node having specific aux properties set, and we use this quite often. So each node has set moonshot, and this is meaning chassis number. I will explain why it's needed. And it's also have specific, it has specific label set for explain where this node is actually used. For now, this is meaning that this node will be used for the OpenNebula, and all the devices for OpenNebula will be placed only on this on nodes which having this this label. This is also described in the yeah, we can query nodes by the property. For example, all nodes in moonshot 15. And LINSTOR can use the same labels to describe where this where to place exactly replicas. For example, we can check OpenNebula resource group. We can see that we requesting LINSTOR to place 2 replicas, and these replicas should be placed on different chassis. And replicas for OpenNebula should be placed on the nodes dedicated to OpenNebula. For the Kubernetes, it is connected through the storage classes. They are having the same name like resource groups in the LINSTOR. And now let's check the amount of resources created. Yeah, quite many of them. Let's count. First, we will count PVCs, resources created by the Kubernetes. We see 755. Each one is a separated pod or separated volume used by some pod. And now let's check resources created by OpenNebula. 1,892. This includes all the user virtual machines and also includes OpenNebula images. All of them are located in the LINSTOR. And now we can check amount of resources itself or replicas. We have to wait for a while. Yeah, and we have, sorry, a little forward. And we have 7,000 resources, 6,912 resources for the, this is actually replicas, disk lists or data replicas. This is the amount of DRBD resources itself created in our cluster. Okay, let's go forward. Now I want to mention some problems which we faced with using LINSTOR and how we solved them. First is simplicity of deployment and updates. Here is more node than problem because we put all LINSTOR into containers. For now, to update the LINSTOR, it's just a matter of reboot, just update Docker image and put it into Kubernetes, new configuration to Kubernetes, and it will just roll out the new release. So to update the control plane, you just need to shoot down all existing control plane and running new control plane with a new version. This is working without any problems, with no outage. The second thing is authentication and authorization. We started using LINSTOR from the beginning. First, it has no any options to secure the communication between the controller and satellites and clients and controller. But after a while, there were added mutual SSL authentication, so you can add certificates. It is already automatically done in my Helm chart. So if you will use it, it will be done automatically. And it will secure the communication between all the components and between the API and drivers. So this is working fine, but for now, there is still an opportunity to split a LINSTOR to having there more roles, more users. If you are cluster admin, you are cluster admin. You can freely doing everything in the cluster. I think it will be solved in the next year or quite soon. The next thing is scaling. LINSTOR is scaling quite fine horizontally, but vertically, I've tried to create node with 1,500 resources, and it was taking about 10 minutes to load all these resources each restart. So for now, we decided to not use nodes with big amount of resources, but better to use more nodes. First versions of LINSTOR were also having API changes quite often. It's like baby diseases, but this is more likely not question to the LINSTOR, but to the Kubernetes, because I was forced to update our PVs to handle all these changes, and it was quite painful. But I handled that. It can be solved. We were updating first LINSTOR were using flex volume driver for Kubernetes. After that, it was changed to CSI, and after that, CSI format was also changed a little. So we were needed to update these devices in the Kubernetes and also in the LINSTOR. For now, I don't see these problems quite a long time. I think this is also solved. And for now, LINSTOR has stable API. I think it shouldn't be a problem for now. Scheduling of thin provisioned resources. We use thin LVM because we need snapshots. This problem might be connected when you creating. This is, I mean, if you create some volume, for example, 100 gigs, from the beginning, it can take just a few megabytes. And if you have some node which is totally free, and you create some big amount of resources, for example, 10 or 100, all of them can be placed into one node. And after they will start growing, you will need to relocate them somehow because node will have lack of space. To solve that, by our request, again, guys from the LINBIT were implementing special scheduling algorithms where you can specify various strategies, how to put resources, and it is also, there is a few strategies which is recommended to use with thin provisioned volumes. So if you use a thin LVM or a thin ZFS, thin volumes on ZFS, better to check this opportunity of the LINSTOR and configure scheduling for the scheduling policy. The second thing is DRBD model updates. And this is really, how to say it politely, I don't like this. This is a really difficult procedure. To update the DRBD model, you have to, on some node, you have to migrate every virtual machine or every container which is using DRBD there, then shut down all the resources to free up this DRBD model. And after that, you can inject a new one. This is usually not so easy, but in our infrastructure, we compile a DRBD model in advance before it's getting into node. So we're distributing it with a system which is booting over the internet. So for now, to update the DRBD model, we just need to reboot our node. But this is also not so good. This is fine for virtual machine, which can be live migrated. But we have now all our services in Kubernetes well written. And some of them can't be migrated without downtime. They are running with just one replica, and this is just a painful thing of DRBD. But otherwise, DRBD has really cool performance because it's working in kernel space. And you probably have to pay for this performance by the simplicity of updating DRBD model itself. Why do you need to update DRBD models? Because sometimes there is still some bugs. Every software has some bugs. And this is always better to keep on the latest version of DRBD. But this is not so easy, trust me. Okay, let's go forward. Let's talk about monitoring a little. First, when we started using LINSTOR, we were monitoring it. First, we use Prometheus, or for now we use Victoria metrics. It's working the same way like Prometheus. It's working with the same format of metrics. And we wrote simple exporter on shell. There were just 4 lines on bash, which is just extracting needed data from the LINSTOR, because you can query all the information there through the API, and you will see standard JSON output. And we were parsing it and using it for a long time. For now, LINSTOR has own exporter built into controller, and I found this is really useful. So you can connect Prometheus to your LINSTOR without any additional exporters and install it. And the next thing is read-write many. This is quite popular question. We also time to time need to use read-write many volumes in Kubernetes, because some applications need to share their state between the replicas. For read-write many, we use NFS server provisioner. Lately, it was renamed to the NFS Ganesha server and external provisioner, which is quite a long name for it. But it is still working, and you can see I also maintain Helm chart there. In short, how's it looking? How's it working? We can create some volume which is provisioned by LINSTOR, let's say some DRBD device. And on top of it, yeah, there is replication. And on top of it, we have controller container with the NFS server and with the controller, which is looking into specific storage class in the Kubernetes and providing the volumes on this container by the NFS by the standard way. So, and this server also has some clients, and it can freely be migrated from one node to another one. This is how we use read-write many for now, but I just want to suggest you use it in really important, use this in really needed cases, because if you can do that without NFS server, better do that without NFS. But if you need it, this approach is working, and we use it for many years already. That's it. A few words about backups. For now, LINSTOR also having on mechanism for the backups. It's called snapshot shipping. It requires you to store latest snapshots on the nodes. But we don't use it for now. For now, we use we have simple playbook, which is spawning jobs for backupping every block device, every DRBD device. And to backup, we use, for the backup, we use Restic, which is working really fine with block devices as well with file systems. But we use it for block devices, and it has deduplication enabled out of the box. We sending all this we're sending all these snapshots to dedicated node with a ZFS rate, and we have really operational backups done fine with just this simple interface. And probably, and to do the backups, you also have to use snapshots, of course, because of the consistency. If you will backup a database without snapshot, it can be corrupted after you recover it. So we use standard LINSTOR API to create snapshot, and after that we're creating container with the Restic, which is taking block device, entry of block device of the snapshot, and sending to the Restic server. And this is working really fine. I'm happy about it. That's probably it. I can answer on any of your questions if you want to. Thank you for attention.
Thank you for the show, Andrei. Let me read one of the questions for you. So the first question is, what shell did you use in the demo?
This is power level 10K. This is really a cool shell. You can easily configure it. This is for ZFS.
Okay.
Power level 10K.
Power level 10K. Okay, never heard of that. So the attendee asking the question was contemplating it is set shell, but yeah, it's power level 10K. Okay.
Most important question.
Okay, then here is a comment. Thank you for your great work with LINSTOR. I currently use it in conjunction with Stolon. Do you see any advantages, disadvantages using Stolon instead of HA etcd? And go first, and I will also add something to that.
I just wanted to say that I was asking to DRBD mail list about this, and I was really happy when the guys were implementing etcd support. I say, wow, cool, you're so cloud native for now. And but I don't remember who it was. There were really a long mail description why using Stolon is better for big environments than using etcd. But I just want to append shortly that LINSTOR can also work with etcd. Go ahead, Philip, please.
Okay, then
you can explain.
Then let me add here a little bit. So with Stolon and the Postgres SQL database in the background, you have, let's say, an additional level of, I'm not sure if security is the right word, but we have constraints in the databases, in the database, making sure that everything is consistent within the database. And this type of constraint system, that's not possible on etcd. On the other hand, I see that etcd has its advantages in the cloud world because it is like Kubernetes native. I think Kubernetes itself also relies on a etcd. But still, our recommendation when it is for a really big deployment, like in this case, we recommend you use one of the SQL databases. So first recommendation, Postgres.
Philip, have you checked performance between the etcd and Postgres?
I'm not aware of performance differences in that area.
Mm-hmm.
Okay, then let's jump to the next question. I just read it first. You were rebooting the nodes in your crash test. How did you determine that data was lost after reboot? You mentioned CFS. Any reason to use it instead of ext4? On how many nodes do you replicate? Do you use replication across your data centers? If so, does LINSTOR DC aware, and will it, in case replicate failure, make sure to create another in separate DC? Okay, I need to decode that one. Okay, but
okay.
maybe let's start with the first one.
Okay, I will start from the replication question. We use various strategies, and this is mainly depend on the workload which we're running there. For example, for the hosting, web hosting and databases, we use separate storage nodes, which is running on the same moonshots. There is up to 4 NVMe devices, and all data is located there. We usually use 2 replicas to replicate between these storage nodes, and one diskless replica, which is running on the compute node without drives, where pods just need to have access to the data. For the OpenNebula, we use 1 NVMe drive, so 1 terabyte installed on each cartridge in our environment. And usually virtual machines are created and scheduled on the same place where the data is running. This is done for the data locality. Yeah, I just want to append, there is also an opportunity to schedule Kubernetes resources into the same place where volumes is located. For doing that, Stork extension is used. What was the question also there? Yeah, replication across the data centers. We have really stable channel between the data centers, and we are not still prepared the communication between them for now. But yeah, they will have a really stable channel. There is optic fiber. I don't know how many fibers inside. And we're going to provide this opportunity to replicate the data across the data centers. And we will provide it as a service as extended service for existing one. And it also will be based on the LINSTOR.
May I ask, how far are the data centers away? What is the distance between them?
It's a very small city, and we have it's like on 2 different points of the city. I don't know how many kilometers. I just don't want to say. I don't want to lie you.
Okay, if you would walk from one data center to the other, does it take you like half an hour or 15 minutes?
If you're walking, you can go for 20 or 15 minutes, I guess.
Okay.
If you are on bike, you can go faster for like 10 minutes.
Yeah, so must be in the range of a kilometer.
Probably.
Okay.
Please.
Yeah. Okay, I think the first part of the question was about rebooting. So I read it again. When you reboot the nodes in your crash tests, and I think that refers to the slide where you compared the different technologies. How did you determine if the data was lost? I think that's the question.
I can talk about that really long time, because this is subject for different speech. But shortly, to answer it shortly, I can explain that test was performed by running some script which was generating the data, and the other nodes where the data was located were somehow stopped immediately, or there were injected devices and disconnected the network, something like that. And this test was running in single instance, and after a while it was also running in cluster-wide. So many nodes were writing some data. After that, we were shooting down all the chassis where these tests were performed. And after that, after reboot, we were checking where this script was stopped and was it able to mount file system and read this data.
Mhm. Yeah, I can add from the Linbit side. I mean, we do similar things on when we test DRBD, and we started to use a special mode of FIO. So FIO, the block IO benchmark tool, and it has a mode where you can write a certain pattern and then at a later point let FIO verify it. So we use
Wow, I didn't know about
FIO
it.
for that.
We were using FIO just for taking the performance and counting it, but I didn't know that. I will definitely check that.
It has this verification feature, but we found out that apparently it's not version compatible. So when we learned the hard way when you replicate from a RHEL 6 to a RHEL 7, we have different FIO versions, and then the verifies delivers you a false positive.
Yeah, you always should use the same file version. I just want to append. Yeah, there were also questions about ZFS versus LVM and why we chose LVM. First, we were using ZFS. And this is also interesting thing. Our hardware is quite new, and there is also hardware bugs where it's running. We're trying to run production on this hardware, HP. This is there were bug which is connected with the NVMe and new Linux kernel. Sometimes it was stopping writing or writing some holes. I don't know for sure what is happening, but after all, some data was corrupted. And when we were using ZFS, it was also blocking all operation with the node itself. The only opportunity to restore this node was to remove ZFS totally from this node, create new ZFS, and start using it. Starting from the LVM, we have no such bugs, and I hope they're solved by the DRBD itself, because time to time we have some resynchronization, and this is working really fine. Another thing is that ZFS has own cache, which is taking part of RAM. With the LVM, you don't have to use it. And after all, I don't see much difference in ZFS and LVM if you're using it for the block devices. I think they're working quite similar. And as about benchmarks, LVM was even a bit faster than ZFS. So why not use LVM if there is no difference?
Right. I see. From my point, I see there is many strong opinions about ZFS or LVM. So we usually let the user decide which of those technologies they want to use. Okay, then going to the next question. Does LINSTOR support snapshot shipping? Do you want to go first, and then I can add a few words?
I just can add that I was playing with that a little. It was added just in latest releases, and I had no time to implement it fully. To me, it's working really. It's a little bit weird to me because it's not usual like in other clustered file systems. But interesting thing that you can deliver snapshots and end device shouldn't be DRBD itself. So I'm going to use it for the backups, but I'm still not sure about it. I need to inspect it more. Go ahead, Philip.
Yeah. Yes, so it's a very recent addition to LINSTOR. And I need to add that the beauty of it is that you can configure it to do continuous snapshots, and then it only ships the deltas between the snapshots to the remote system. And it is, if you're using LVM as the backend technology, yeah, it works in that environment. It also works in the ZFS environment. And there it uses CFS send and CFS receive. And yeah, and I can also provide a little peek into the roadmap. What we want to add in that area is that we also want to ship the snapshots and the deltas between the snapshots to a S3 compliant storage so that you can use that as a
Wow,
backup
that will be
target.
a really cool feature.
It's planned. Let's see when we get it out of the door.
Yeah, I just want to say that this is really cool that you can set up single system for the storage and use also internal features for the backupping. Because if you use OpenNebula, if you use Kubernetes, if you use Proxmox, you have to use 3 various systems of the backupping. If we have this in the LINSTOR itself, it should be really fine to have it.
And even allows you to move a volume from, let's say, OpenNebula to Proxmox if you decide to do, right?
So you're going to implement it?
It's going to come. I cannot yet give you a date, but it is on the roadmap.
But do you mean move from one LINSTOR cluster to another cluster, or to move it between the clusters?
Well, the first thing is to get it to S3, and then to get it back from there. And in the moment LINSTOR has this feature, then that already allows you to back it from one LINSTOR cluster to S3, and then restore it into another LINSTOR cluster, right? So step by step, we are adding features and features. Okay, coming to the next question. What is the maximum number of DRBD resources per node? And I let you go first because you did experiments, and I will add something.
Yeah, I did experiment. I just wanted to use DRBD with the protocol A. Who don't know, DRBD has various protocols to synchronization. By default, it's protocol C. It's like synchronous. It also provides semi-synchronous and asynchronic replication. And my idea was to use LINSTOR without snapshot shipping. It wasn't implemented yet. And I just wanted to have backup server with all diskless replicas connected on it and go all over them and make backup for them through the asynchronous mode. But we decided do not use it because there were 1,500 resources for each virtual machine in OpenNebula. And it was causing some problems to boot. When you're starting the cluster, it was blocking it for 10 minutes for each node where these resources were located.
Yeah.
And for now, it's usually, we have no much resources. We're using really fat containers. So in matter of hosting, we use like 2 or 3 devices, discrete devices connected on the compute nodes. And the storage nodes might have, I don't know, up to 50 resources, maybe 100 sometimes. We have some nodes like this. And OpenNebula is usually like 10 devices per host.
Yeah, so I can add to that. So the number of 1500 is what I use as the maximum number of DRBD resources per server. And we started to work on that area, and soon we will release an improved version of the DRBD utils, and that should be then able to scale to the area of 2,500 resources per server.
Do you plan to write it on Go?
Not as of today. But yeah, so that's coming, but I don't see too many users wanting to have such high number of resources per single server. But yeah, you never know what users come up with, using big chassis all full of NVMe drives. So maybe someone has like 2,000 resources on a single server. Okay, so that were the questions I see here in the Q&A section of our Zoom software. So one question I want to ask is, you mentioned that you're using OpenNebula and Proxmox, and I didn't got why you are using 2 virtualization systems.
I can explain you. These virtualization systems were created for different purposes. And OpenNebula is more likely cloud platform. It's really fine to quickly run hundreds of virtual machines and schedule some tasks to them. But it is not so good for having long-term application. I usually call it pet sets, where you should carry on them. Proxmox has already existing everything needs to have backups. It has a high availability manager, which is working out of box. And it is really fine solution if you need to put some virtual machine and you want to let it working forever. It will always keep eye on your virtual machine, and it will always running. You will have backups for it, but it is not so. Proxmox does not provide the flexibility like OpenNebula does. So if you need to create hundreds of virtual machines, better use OpenNebula. If you need to single instances, better to use Proxmox.
Okay, got it. Okay, so I think that were the open questions. So
I just want to ask to you, because I saw some work in Linbit repositories that you were working on KubeVirt. Have you tested it somehow? Because we are also considering it to the future.
Yes, so KubeVirt, I don't know how to pronounce it. Yeah, so for the audience, that is a technology, I think, mainly driven by Red Hat, so that Kubernetes can manage KVM-based virtual machines. And we verified that the LINSTOR CSI driver works nicely with KubeVirt. I might be wrong, but I think we needed to do a few minor tweaks to it to make it work. And we also verified that live migration with KubeVirt and CSI driver and DRBD is working.
Wow, that's cool. That's exactly what I wanted to have.
Yeah, it was a goal that we get that working, and I don't have all the details at the top of my head, but live migration is working. So this is what was stuck.
Mhm. Okay, that's fine.
Okay, then to the audience, last call for questions. Okay, and I think we will have the recording of this session online soon, and there maybe Niels wants to add a few words at this point.
You're right. You're correct in that, Philip. Like the recordings and the slides, we will send out to all attendees in the coming week. And yeah, I felt highly entertained in that webinar. I think Andrei was very exciting to follow you, and I also thought it was quite nice to see that you guys also had a dialogue in the end and like questions to each other. That was very nice. And I hope to see most of you in the next hour. In exactly 1 hour, we start with the last and final installment of LINSTOR Days. And you can ask and interact with our LINSTOR developer team directly. We can allow you to speak, so you can. That sounds a bit. we can turn on your mic so you can talk directly to us. That's possible, and I think that's going to be just a really nice dialogue.
Okay, thank you, Andrei.
Thank you.
Thanks, everybody.
Thank you for attention. Bye.
Bye.
Bye.